this video we're going to go over how to solve ordinary differential equations using integrating factor. So to use this method of solving ODEs, it has to be in the form dy dx plus py equals q, where p and q are functions of x. And you calculate the integrating factor, which we're going to denote if, as e to the power of the integral of p. So if we do two examples, we have x dy dx minus y equals x squared when y1 equals 3. So we try and get it in this form first. So we have dy dx minus y over x equals x. So now to calculate the integrating factor, it's e to the integral of p dx. Our value of p is negative 1 over x, so e to the integral of negative 1 over x dx. If we do that integral, we will have e to the negative ln x, which can also be e to the ln x minus 1, and we have two e and ln, so this cancels to x minus 1, or 1 over x. So now that we've found the integrating factor, we are going to multiply the integrating factor by both sides. So we have 1 over x, we have dy by dx, and we have the minus y over x equals x multiplied by 1 over x. Now for this left side, it's a general rule that once it's in this form and you multiply it by the integrating factor, it's equivalent to the differential of y multiplied by the integrating factor. So if I write that down, we have the differential of y times the integrating factor. This is applied to every method when you solve by integrating factor, and I'll be doing another example so you can see. So that's what this is equivalent to, and this is always the case. So if we do that in our case, we have d dx y multiplied by the integrating factor of 1 over x, and of course our right side, x multiplied by 1 over x, that just gives us 1. So now that we do that, we take the integral of both sides because we want to get rid of this dx. So on this side we get y multiplied by 1 over x equals x, and because we're integrating we need an integration constant plus c. Then to get y by itself you multiply x, so you have x squared plus xc. Because it says where y1 equals 3, that means we need to find the integration constant. So where we have 3 equals 1 squared plus 1c. So I've just substituted in 1 for all the x's. So we have 3 equals 1 plus c. In quick maths we can see c is 2. So our solution is y equals x squared plus 2x. If we do another example, so we have x dy dx plus y equals x cosine x. So again, we're going to try and get dy dx by itself. So dy dx plus y over x equals cosine x, because the x's cancel. So now that we've done that, we need to find our integrating factor. if equals e to the integral of coefficient of y, which is 1 over x, with respect to x. So that gives us e to the natural logarithm of x, which is known as, which is the integral of 1 over x. That just means our integrating factor is x. So now we're going to multiply the integrating factor by both sides. And we mentioned on the previous page, when you multiply the integrating factor by the left side, it means the differential of y multiplied by the integrating factor. So for this case, we still have x cosine x, and then we will take the integral of both sides. So we have y multiplied by x equals, now for this one, this is integration by parts. So I always have to do it separately, but yeah, I'm just going to do it. So we have integration by parts of x cosine x dx. So if you're not familiar with integration by parts, I've done a separate video on it, but the basic rule is when you have a formula that looks like this, so this is the differential, and you do it using this formula, so that's a u v minus the integral of u v, the little subscript that looks like an apostrophe, that means the derivative. So we're going to be using this formula for integration by parts. So we're going to assign v as x and u, the derivative of u, as cosine x. So in our formula we will get vu, so v, and then we would integrate cosine x, and the integral of cosine x is sine x, so x sine x minus the integral of u, so we'd integrate, so we'd have sine x, and then the derivative of v, the derivative of x is 1, so we just have sine x. That leaves us with x sine x. The integral of sine x is negative cos. Negative is plus, so we have plus cosine x, and then we've got the plus c because it's constant of integration. So now that we've integrated this, we can plug it back up here. So we have x sine x plus cosine x plus c. And now that we've got that, we can divide everything by x to get y by itself. So thankfully we weren't asked for the specific solution. We've just got a general solution involving y equals. And that's it.